All right, hey everyone, welcome. So this is an IEEE technical seminar, if you like, from the IEEE Queensland Chapter of the Computational Intelligence Society. My name is Marcus. I'm the current chair of that little corner of IEEE, and yeah, for people, if you're in Queensland in particular and you're interested in IEEE and getting involved with IEEE, feel free to get in touch with me. It's a great organisation to be a part of if you're in the computer science or electrical engineering sphere. So yeah, today I've got John Hawkins with me, who's an old mate of mine, I suppose, but it's fantastic to have you here, John, um, and to have a bit of a chat, I guess. But John's been um, doing a lot of work in recent years in the, I guess, data mining was previously the buzz term. Maybe machine learning is a little more what people say now, but very much the same thing, right? So John's been doing this kind of stuff with in the real world, as opposed to kind of mostly what I do, which is research at university. Um, and yeah, that we thought it'd be great to have a bit of a chat about, well, in particular about the book that you've written, John. And I have to say, it's such a nice book, such a well-written book. I don't know whether to give it to my students for the data science content, or whether just to give it to them as an example of how to write well. It's very nice to read. Well done with that. um, so John and I think we're just going to have a bit of a chat about that, and it's going to be very practical, I think, because the book is a very practical book. And we'll have time for questions at the end if we have questions. So yeah, thanks for joining me, John.
You are welcome. Sorry, I'm just going to turn sound off on this machine beside me so it doesn't ding and beep away while walking.
Yep. No problem at all. Yeah. So do you want to just start by introducing yourself for a couple of minutes, telling people what you've been doing, what you're interested in?
Yeah, absolutely. Thanks so much for the intro. So I met Marcus when I was doing my PhD in the group up at University of Queensland, and at that time I was focused on machine learning applied to molecular biology. So we'd all talk about machine learning in general and different problems, but I was part of a team. We focused on particularly what was sort of sequence analysis. So, given a protein sequence or a DNA sequence, predict some properties of it. Like, for example, whereabouts in the cell a newly formed protein would be transported to. So there was a lot of really interesting problems there. We were working on a lot of stuff with recurrent neural networks. Interestingly enough, at the time, I tried to make use of the LSTM, but perhaps the data sets we had that then weren't large enough, but it didn't work anywhere as well as simple Elman recurrent neural networks. And I still kind of hold out some skepticism that people sort of jump to LSTMs too quickly these days. But anyway, we also worked, like I remember Marcus and I spent a lot of time trying to work out how support vector machines were working at some point, like when they first came out, because of those of us who'd worked in either in neural networks or evolutionary computation, this was a kind of like a fascinating new development. And we spent a bit of time working on kernel design for a bit, and then hybrid architectures with neural networks and support vector machines, all kinds of things. So good times were had solving all kinds of different problems. And then at some point in my career, I did a couple of postdocs, and I was in Germany, and not sure if I wanted to stay in academia. And so just started this process of doing contract work, building different kinds of data mining, machine learning systems for companies. And that ultimately, I just followed that trail for quite a while, because it turns out there's a lot of interesting problems, for machine learning. This was kind of like the peak of the beginning of the data science hype. I think the Forbes article that was sort of saying data science was the sexiest career of the 21st century had just come out or was about to come out. So a lot of hype. And so actually some of the themes in the book are about kind of dealing with that hype when you deal with people who've been given kind of fairly inflated expectations of what you're going to be able to do with these techniques. But it's an amazing career to be in. You get to sort of the thing that's good about it is that these techniques are sort of, I guess, general purpose enough that there's many different kinds of businesses or NGOs or organizations that can benefit from this. So as long as you have the kind of humility to make sure you ask good questions and understand the domain you applying them to well enough, you can do really great things. So, I worked in media companies, banks, software companies, and I'm back working in an ad tech company called Playground XYZ, which has been acquired by an American company called GumGum. But as always, the attention is always building machine learning models, sort of solving problems for different kinds of business clients.
Excellent. Sounds super interesting, John. All right, so I reckon I'm keen to get into this a little bit and talk some tech with you. I just want to, I'll bring us back in a second, but maybe just to pop up at least the cover of your book there, so people can see John's book, Getting Data Science Done, Managing Projects from Ideas to Products. Yeah, I sort of had a look through the book and almost immediately started reading things that rang bells in my head that were very familiar with the kinds of things that experiences that I've had in the past as well, because yes, I am an academic. I've done a fair bit of applied machine learning, aka data science, with various companies and other organizations. A fair bit of it's been focused in the healthcare space, doing data analysis in projects with Queensland Health. Not at the level of analysing people's blood test results or image scans or anything like that, but more at the healthcare system level. Like, what do we patients are going into this hospital system. How do we make sure they don't come out with a problem that they didn't have when they went into the system? That kind of thing. So yeah, I when I started reading the book, I thought, oh gee, this is a lot of deja vu for me about the kind of experiences that I had there. I mean, so early on you talk about the need to have a clear problem statement in a data science project. And I immediately I thought, yes, I think it's often the case that you have this experience where somebody wants to do a machine learning project. They want to apply machine learning. They want to do data science in their domain. Essentially what that means is they have some data and they think it's very valuable.
Yeah.
Okay. But that's about as much as they think. And so they come to you and say, we've got this data. It's really valuable. Can you please extract that value for me? Yeah, so that sounded a little bit like the kind of thing that you'd experienced too, John.
Yeah, 100%. And I mean, like, to be fair, there's like certain kinds. One of the distinctions I try and draw in the book is that there are, like, all data science problems tend to lie somewhere on the spectrum of being entirely problem driven versus entirely data driven. So and at the extremes, there are examples of businesses that had large data assets and they were looking for ways to try and monetize them. So an interesting example was, I think there was an online website that had in Germany that had they were selling, they were like a kind of classifieds for used cars where people could buy and sell cars. You know, this kind of thing's super common these days. And they had this massive data set of all of these cars and the asking and the sale prices. And so they ended up working out how to repackage that and sell it to insurance companies for the valuations of like expected market valuations of cars. So there
Yeah.
are entirely data-driven problem, but most of the work that most data scientists do sit closer to there's a business problem that needs to be solved, but then you're often dealing with there's someone who's very excited about a particular data set and wants their data set involved in the solution of that problem. And so you kind of, I think one of the things that I'm trying to make clear in the book is that you can come out of academia having like an excellent grasp of all of the tools and techniques to use, but there's a whole bunch of political and social and organizational structure things that influence how projects go that you can be completely blindsided by.
Mm. Yeah, absolutely. Yep. Yep.
So one of those is like just understanding like why someone wants a certain data set involved. Like, you know, it could be things like a certain person has managed to secure funding on this project under the guarantee that they make use of some data set because someone else in the organization is helping to fund it, and that data set's their kind of baby project. So there's sort of political
Right.
connections all over the place that you sort of have to deal with. And you know, like one of the hard parts of data science in industry is kind of finding that, walking that line of just pushing to get a practical solution to the problem, but navigating the kind of the unavoidable political elements of being inside a large organization.
Mm-hmm. Mm-hmm. Yes. Yes. I mean, I think at one point I had, we'd got some funding for a project, which was partly government funding, but also coming from the industry. And um, someone much higher up in the organization contacted me and said, "Oh, I want to understand what you're doing with my, in this department, um, with this project." So I went in and had a chat to them and sort of tried to explain what I thought we wanted to do in the grant. And at the end of that, he kind of just looked at me and sort of sniffed and said, "Sounds like a bit of a fishing expedition to me, but good luck with it," or something like that, you know. And I think that's true, right? If it's data, if it comes from the starting point of, we have this data set, we think it's really valuable.
Mm,
Can we want we want to take advantage of this. We want some value. You're almost immediately probably in the realm of unsupervised learning as opposed to supervised learning, because if you start talking to them about, I need labeled data
yeah.
to do something useful, then very quickly we don't have labels, we just have all this
Data.
data,
Yeah.
figure something out. So, and I and yeah, I think my experience has been, at least unlabeled techniques that just work on unlabeled data um, are a lot more important than you kind of might get from doing a machine learning course or something like that. What do you
Yeah.
think?
Yeah, I mean, they're certainly very useful. The problem, the question I always have though, whenever someone is going to latch on and do an unsupervised approach is to ask how you're going to evaluate the results. And inevitably, you need labeled data to perform some kind of evaluation. If not, at the very least, you're using a human being as a kind of like as a query system. You give them what you've discovered and they come back. So they're kind of the source of your labels, which is fine as long as
Yeah.
you're aware of that right from the very start.
Mm. Yes. Yeah, that was exactly my experience. You end up doing some clustering or some sort of rule mining or something like that, and you go back to them and say, "Well, we think we found these clusters in the data, and
Yeah.
this is what this is sort of the attributes of this, and this is the attributes of this. What does that does that have any meaning to you? um,
Yeah.
yes, I think, and one of my other favorite ones here is um, people who think they have a vast amount of data, but it's the P versus N kind of thing. It's like the rows versus the columns, right? So they have data which has 100. It's measuring people or turtles or something. The objects they deal with. They have hundreds of different measurements, and they have 50 rows. So immediately you're in machine learning land. That narrows down the options quite a bit, right?
Yeah.
Um,
Yeah. So, I mean, and you get it's funny how often you get both. There's sort of multiple extremes to that. There's we've got lots of data about very few instances, or there's like we've got enormous numbers of instances with very few data points.
mm,
You just like you've got billions, but you only know three things about them. Um, and or the kind of the orthogonal one, which is you've got enormous amounts of data, but by the time it gets to you, it's been through 10 different processes and it's accumulated errors the whole way.
yes.
So there's like so an anecdote I remember like from the large bank I worked at, um, you know, because we were sort of like operating as a kind of internal consultancy dealing with different parts of the bank, and you'd get data sets that you sort of do quick visualizations to try and understand, and you see this pattern where the 1st of January at the turn of the decade, so 1st of January 1960, 1st of January 1970, there's massive peaks in all of the birthdays. And in particular, I think 1971 might have been or 1970 was a bigger peak as well too. So it's just, you had all these different source systems, all of which had different default dates for birthdays if a null value was applied. And so it was
Yes.
like just these things were sort of, and they were being used to calculate ages, and those ages were then being used to sort of add other flags and characteristics or sort of disqualify people for certain products or whatever. So you had like the kind of the effects of these errors early in the process flowed through the whole data set.
Yes, that's right. Yep. I've definitely had that kind of experience as well. Yes, feels like dates of birth or other, yeah, date type stuff and different formats and things is just uh people the client sort of doesn't really understand that this could be a problem, but machine learning models can't just figure this out. Um, yeah, that's a really good point. Actually, I might that sort of leads me into something else I was gonna talk to you about. So again, I'll just put up one page of out of the book, John, because I like these pictures. um, and so in chapter 11, you're talking about data familiarity and advocating a fair bit for having a look at the data.
Yeah.
Um, and I always try and do this in the machine learning class I teach, try and sort of start the course off by getting students to stop, just don't think for a second about trying to apply massive deep neural networks. Just have a look at the data and think for yourself and use your visual system to kind of um, to think about what the data might be and what kind of thing we might be dealing with, right? So you sort of in this picture you make the point of that just some simple scatter plots of pairs of variables can give us very interesting information. All right.
Yeah, 100%. So it's like, I mean, this kind of plot's reasonably similar to the kind of thing you'll, I guess, in any kind of data mining, data science textbook. There's a couple of things that are unusual, like I've included the non-bijective class,
Yep.
and I don't think that's something that people cover kind of enough. This idea that there can be relationships that are not captured by linear correlation, but that can be seen as soon as you visualize something. I think that's, you
Oh,
know,
yes.
it's perfectly captured by, there was a study a few years ago, I believe, where statistics students in a master's degree were given the same data set, but only half of them were given a hypothesis to investigate. The others were just asked to sort of see what they could discover. And the ones that hadn't been given the hypothesis discovered that it had to be synthetic, because when you plot two of the variables against each other, you got a gorilla, the face of a sort of gorilla. So it was,
Yes.
yeah. It's kind of become a famous paper. And like one of the interesting conclusions is that a hypothesis can sometimes lead you astray. I don't know how strongly we want to believe that, but I think it's also a good sort of story just for having a look at the data and thinking about those relationships. So I think that but one of the things that I kind of like, I wanted to sort of point out in this chapter, which is a little bit different from your sort of typical chapter on this topic, is that in the real world, often data doesn't look like this. Like most data is, so actually you could make a distinction. The vast majority of data scientists end up working on systems that are in some sense related to human behavior, which is kind of inherently stochastic, at least until Elon Musk has stuck a chip in all of our heads and we're measuring every single neuron activity in every single data set. Until that happens, the data sets are stochastic. So unless you're working on sort of like telemetry systems for factories where arguably things are kind of mostly mechanistically causal, most human data it tends to look like basically a blob of dots with some vague elongation in one particular direction or another. So sometimes, ironically, when you see clean patterns like this, it's a stronger indication you've got a problem, in that one of your variables is actually just being defined perfectly on the basis of another. So sometimes you'll see like, one potential way that you can get target leakage is when the client has defined the thing that you're trying to predict on the basis of a couple of the other variables in the data set. So but like they had to have observed that other thing in order to define the target, and you don't get that observation at the time when you need to make the prediction. So as well as just getting a sense of potential transformations of the data, visualization is just a great way to find problems.
Yes. Yeah, you're right. And I think, I just from what you were saying before as well, when I get students to do this, try and give them a real world data set to have a look at this stuff. And often they see some things like this, but often they just see really boring stuff like little horizontal lines or vertical lines, and I say, well, okay, so what do you think we're seeing here? And sometimes they're a little, don't know what to say. And I go, well, it kind of looks to me like, the data is just recorded as integers, or it's recorded with very small, limited precision, or maybe the variables just, you've got a binary variable, and then when you plot it against other things, you get stripes, and that tells us something interesting. And then, of course, when people read a standard machine learning book, or go take a course or whatever, you hear about a lot of machine learning techniques that kind of assume that each variable is a real valued number, continuous variable. I think, and I sort of wonder, well, I wonder how it would deal with all these stripes, but I usually don't go into those things in lectures. But this is the kind of some of the gap between sort of theory of machine learning and machine learning in practice, right?
Yeah.
And I think, like, one of the things I really like about your book is that it talks about this, and there's very few, essentially no machine learning books will talk about all of this sort of stuff that you have to deal with when the data is real world. They just like to stick in the theoretical every variable's continuous, every variable has a Gaussian distribution or whatever, and it'll be fine.
Yeah. Yeah, yeah. It's funny you should say that. So, oddly enough, the book, it didn't turn out the way I'd originally intended it. So when I started the book, I was very excited to be working with this big team of data scientists from heaps of different disciplines. Like there was an econometrician, a biomedical engineer, a pure statistics PhD graduate, I think like a couple of computer scientists, someone else from some other discipline, I can't remember. Anyway, and I thought what I'm going to do is I'm going to distill out the fine details of how they do all of their variable selection, their transformations, like their thought processes. And as I started working with them on different teams and projects and talking to them, it became super clear that most of the reasons that projects worked or didn't work wasn't about the specific techniques they were using or what they're familiar with. It's mostly about just how they communicated with people and found all of the problems before the problems found them. So, like what, like a kind of, and the reason I interject that is I want to say this, that stripes idea. One of the things that I think is really important about there's a combination of data visualization and question asking, which can go really, really well, which is that you should be asking whoever your stakeholders are, business executives, product owners, whoever they are, what the data, what's the domain of the data? Like how old, what's the spread of ages of the customers? What's the regions you operate in? Yada, yada. Like anything that tells you the kind of constraints and domain that the data should come from. And then when you visualize it and you see, hang on, we've got like this product should only be available to people 18 and old, and we've got a bunch of 16-year-olds, or like we know that most of our customers are middle-aged, but actually it's only 10% we see there. You can go back and say, this is what I'm seeing in the data set you've given me. Are you sure that this is like, and sometimes that'll spark a case where they go, oh yeah, well the problem is this day, like our business has changed a lot and maybe there's a 1-year gap between the logging system and before the data makes its way to that system where your data has been extracted for. So now all of a sudden, your data's a year old or something. But the other problem can be is that this is potentially slightly controversial, but something I've seen in a lot of organizations is as people move up the kind of ladder, they get more and more distanced from what actually happens kind of on the front line of their business. And their ideas about the business become sort of more and more mythological in a way. So they don't really know what's in the data or how things actually function. And you have this kind of like political tension where because what will happen is your sponsor will be an executive with the money and the ability to fund this project who's got ideas about how the business works. They will give an order to some low-level data admin or DB admin or whatever to extract a data set for you. And no one's ever challenged them and said, like actually that data you think exists doesn't actually exist.
Right. Yes, absolutely. Yeah.
And so sometimes, like it's actually like I think sometimes data science in industry is kind of like being a therapist. You're basically helping this dysfunctional family realize things about its own business operations and the quality of its own data.
Right. Yeah, and I mean, I think you do a very good job of in the book of kind of explaining why data science is really not very much like software engineering, for example, in the sense that people might expect that they're paying for some kind of product that will do X, Y, and Z, but in data science, you can't really think about doing it in that way in terms of building some box for them that's going to do the thing, right?
Yeah. The outcome's not guaranteed. Like it's not guaranteed that you can predict which customers are going to churn. And
Yeah.
you could predict which customers are churn. It's not guaranteed that you can intervene and actually prevent them from churning. Neither of those things are guaranteed. Whereas it is guaranteed that you can build an app that when you press this button, like XYZ happens.
Yeah, that's right. Yep. Yeah, for sure. Um, all right. So I was also keen to talk a little bit about actually a bit of the machine learning, because that's what the kind of guy I am, I suppose. And you've got some of that in chapter 15. But,
Yeah.
even just before that, looking at these plots again reminded me of something that happens a lot or something I see students do a lot, and I know why they do it, but it's not right, and I don't sort of know what to do about it, right? So there's this classic steps of data mining that I think if you go Googling and you look at free video series of lectures on doing machine learning, whatever, you'll be presented with certain sort of steps,
Yeah.
right? And it's like, these are the 8 steps to doing a good data mining job. Step 1, step 2, follow this and you'll be fine. And one of the steps, or something that happens a lot, is people take their data and do scatter plots like this, of all the variables, all the pairs of variables, and then they calculate a correlation coefficient between all of those pairs, right? And then they remove a whole bunch of variables that are highly correlated with some of the other variables.
Yeah.
Because of course you would want to reduce the dimensionality of your data and simplify your life. But the problem with this is that not all relationships are very well captured by a linear correlation coefficient, right? Which is exactly what you were saying about that non-bijective case there. Yeah, I don't know if you've had any experience along those lines, John.
Yeah. Yeah,
Yeah.
I think, like, 100%, like, you certainly see, I see this all the time, like in the process of like interviewing data scientists for jobs, or talking to people, that kind of recipe book approach. And you can understand why, really, because people are just trying to acquire skills, do jobs, deliver projects, and move on. So you can understand why that mindset persists.
Yeah.
I think it's so it's like one of these things where it's like it's an approach that can bootstrap you into a career fast, but I think it ends up holding people back, because ultimately data science ends up being thinking about what is the data generating process, and then how is my understanding of that data generating process going to allow me to design the right system for it. And the reality is that collinearity, like if it's perfect collinearity, it's almost always because it's a mistake. Like someone has duplicated a column or defined one column off another or something like that. Partial collinearity exists all through the world. Like that there's almost no useful feature that isn't partially collinear with some other kind of feature, unless the information relationship can't be at all captured by a linear relationship. So I actually think I prefer. I think I've become I've become convinced over time that actually the core skill of data science is being able to understand the problem sufficiently and the data generation process sufficiently, such that you can design the right testing procedure to work out if your algorithm is doing the right thing. And then if you can do that, then you can experiment and throw different variables at it. It doesn't matter if they're partially collinear or not, because if you've got the right testing procedure, it's the thing that tells you whether you found the solution or not.
Mm. Yes, that's. I mean, I think I agree, but now I want to sort of
Challenge it.
challenge this a little bit, right? Because there's the other side of this is, as a computer science. I mean, computer scientists, I think, love to they love to automate things,
Yeah.
right? And in AI and machine learning especially, right? So now you have, on the other side of this coin, you have people doing auto ML,
Yeah.
right? So, roughly speaking, auto ML is about coming up with software or systems or algorithms or whatever that do everything for you in some loose sense. So choose the model for you by, I don't know, by taking, you give it the data, it takes every machine learning classifier that's implemented in the Python scikit-learn library. It runs them all. It does a grid search over the hyperparameters of every model.
Yeah.
It does the cross-validation and, tries to, and probably does pre-processing as well, right? Searches over all those and tries to sort of find the best performing model to win your Kaggle competition or whatever you're trying to do, right? But is this really something we can, do you think this is something we can or should be trying to automate in this way, John?
So, I mean, I think AutoML is a super useful tool. And so I guess like for the background, I work for a company called Data Robot, which had like one of the first AutoML tools in the market, or at least the first proprietary ones, before that kind of became a big sector, and then there was lots of imitators. And one of the things that we discovered on the kind of client side is that still, like, the problem is no one has yet figured out how to have an AutoML system work out what the right testing protocol should be, because it's not true that cross-validation is always the right way to go. Sometimes, like, particularly if time is an important factor in like there's a temporal element and that you should be testing out of time, you can't work that out from the data set itself. You have to know something about the domain. Do you know what I mean? So
Yeah.
that's the kind of thing there was always this kind of element of there's a few things that have to be selected by someone who understands what the AutoML can do. From that point, it can save you the time of just exploring the kind of algorithm space. But in that sense, it's just I view it as more like, we've moved algorithmically. You could argue that we gradually automate more and more of the things that we do. Like even a random forest does an internal search to work out where you split things. So it's like random forest is kind of like an AutoML system that just builds ensembles of trees by sort of like putting things together. So I view AutoML as just an extension of that process. It's just got a larger algorithm space to work with, and it knows about it's got built-in systems for how to do hyperparameter optimization, all that kind of stuff. But no one's automated the process of designing a good testing protocol for these things. And so you see, and the reason I think partly is the best possible testing protocol is going to be the one that perfectly emulates what's going to happen when the model goes into production. So, for example, if your model is only going to be applied to customers who are new to the company, it doesn't make any sense to have the same customers in the training and the test data set, because that's not what the real world looks like.
Yep. Yeah, and every real world problem is going to have its own. This is the sort of domain specific stuff, right? Like the ultimate testing protocol has to be something that works in healthcare is not necessarily going to work in banking data,
Yeah.
Yeah, that makes sense. And I even with standard software for implementing machine learning techniques, I'm always rant and rave a little bit in lectures to try and get students to understand that it's you can't just blindly call the random forest function and take what's coming out of it. Well, there's a chance that it might have done something silently that you weren't aware of. In fact, it probably did. It made some choices about hyperparameters, or it made some choices about what to do about null values that you unknowingly have thrown into it, or whatever, right? And I think that's part of the difficulty of doing the whole AutoML thing.
Yeah, I mean that's the kind of thing you see like in some of these kind of like recipe approaches to data science, they'll do things like data cleaning, remove any records with null values.
Yeah.
Except, of course, null values exist in the real world. So you end up people building systems on this perfectly clean data set with no nulls, and then it fails in the real world because the real world's full of nulls.
Right. That- yes, that's right. Yes. Or you can have a you can have a data set which, I don't know, which has a column that records sex as a binary value, male, female. So there are zeros and ones, but then there are also missing values,
Yeah.
and your pipeline process says that's okay. Just impute the missing values by calculating the mean of the column,
Yeah.
and let's fill it. So now suddenly we have a binary column that's got a lot of 0.333 or something like that in it. um, Crazy stuff. Yes. Um, so John, in chapter 15, you talk about predictive modeling and stuff. And one thing that came across is the sort of this um, the idea about complex versus simple models and explainability a little bit, and like the idea that clients trust what they understand, the kind of
Yeah.
thing. I really had that. Very much had that experience as well, where um, machine learning people are always super keen to apply neural networks and fancy things, but sometimes in the end, a simple rule mining thing or a very simple decision tree is what they like, because they can understand what it does and they can't understand those more complex things. Do you reckon now that, I mean, your book is not old by any means, but things are moving fast in this space. So do you think now that we have large language models and all this stuff, are people somehow more willing to accept complex models these days, and not even if they can't understand what's going on inside?
Yeah, yeah. I think so, definitely. I mean, the whole explainable AI field sort of grows and makes inroads, and you see, like, I think um, a lot of that resistance comes, I would say, from parts of the of industry where they've they've got kind of a longer history of using models. So I'll say, for example, in finance, we've got risk modeling, or in marketing, we've got propensity models, where you've got people that have been using sort of logistic regressions or other kind of linear models for a very, very, very long time, and it's kind of core to the way they do business. You've
Yeah.
actually got a generation of executives who've been trained to expect to ask what are the coefficients on each of these kind of variables that I expect to see there, and that's their kind of sense check on whether the model makes sense. Like, I want to see that the things that I know are related to this part of my business that I care about are in there, and I don't want to see things in there that shouldn't be in there. So it's partly a kind of like a generational change, like a little bit like that quip. I can't remember who said it, but the science progresses one funeral at a time. I can't remember who said that, but it's a
I
great
don't know
quote.
who said
It's
it.
the kind of thing, like, in industry and analytics progresses one funeral at a time. Yeah, so, but it's also based on, we've got to have good alternative methods for doing a similar kind of thing. So you see that now with, like, say, all of the different kinds of feature importance methods, whether they're kind of permutation based or Shapley values based, give
Yeah.
you the equivalent of understanding the coefficients in a model. You see things like partial dependency plots give you a way of understanding the impact of changing one variable if everything else is kind of held constant, even if it's a highly nonlinear model. So there's like, and then there's like really interesting techniques where they can tell you just, you know, what's, I think there's Shapley versions of this as well, but there's also permutation-based methods of sort of saying what was the features that drove this specific prediction. You know, like, so basically saying, in some sense saying like, what was it about this record that was highly different from the average value of a record that was kind of driving this prediction up or down? So all of those things are kind of contributing to make that easier. I think it's weird that it's kind of ironic in a way how the moves in two directions. You've got this part of the industry that's been resisting anything but linear models for a long time, even when there were good alternative versions of explainability, like that are comparable to the ones for linear. But yet ChatGPT comes out and all of a sudden people are just willing to throw everything at this thing that's got absolutely no uncertainty quantification whatsoever in the output it produces. It's bizarre, the extremes that exist in industry.
Yeah, it is, isn't it? I mean, yes, it's completely at the other end of the scale, right? When it comes to things like large language models, maybe it's partly because if what you're doing with the thing is generating stuff, it somehow it seems a bit more low stakes than predicting these hard numbers. Although I don't think it is in the end, because people are going to use this use large language models to make decisions. Maybe it's something to do with that. I don't know. Yeah. So yeah, I mean, we should we should spend a little bit of time we have to
On
spend
those
a little bit of
topics.
time talking
Yeah.
about this future stuff, right? I mean, AI, machine learning, even, I'm sure since you did your PhD, the changes have been kind of extraordinary, right? How do you sort of see how do you think about the way it's gone, John?
Yeah, I mean, I think everyone was like, so I had to do a fair bit of work. Like I was kind of blindsided, I guess, by the transformer architecture when it came along, and had to do a fair bit of work to understand and get a sense of why it was working. And I actually think largely like it's interesting. The the real advance that I don't think people acknowledge enough is that it turned out that you could represent semantics in a vector amazingly well. Like we knew we were heading that way because we had word embeddings and they were turning out to be more useful than things like TF-IDF. And we were like, there was incremental advances in representing semantics in a vector. But then it just turned out that multi-headed self-attention could do this to a level that kind of exceeded expectations. So that's where the real advance is, that you can represent semantics in a vector, because the generation component arguably isn't there actually hasn't been that much advance in that direction, because all they're doing is given that semantic vector, produce a probability distribution over the next token or the next word, feed that through them, and then iterate and repeat. Like it's really like there's some advanced algorithms where they maybe do a little bit of branching search, like similar to what they did in kind of early chess games where you explore multiple paths in parallel and then so try and choose one when you get further down the chain. Like they've reused some of those ideas in a different way, but there's not like, as far as I'm aware, there's been no massive advance in how you explore that space. The real advance was representing semantics, and that came from large data sets with multi-headed attention on these sort of massively over-parameterized models. So that's super interesting. And I think what's weird about this is that the general public, it's like the general public has gone through a second ELIZA moment. And so what I mean by that is when Weizenbaum created ELIZA back in the 60s, there's that great anecdote. They talk about how he discovered his secretary and some other people found that they were quite happily chatting to it. They all knew that it was a program, but yet this thing was able to emulate some of the standard processes of human interaction, basically the way a counselor basically reflects things back, and you get some satisfaction of talking to it. It's just that the Eliza moment was restricted to, I guess, the small enough bunch of people who got some value from that very generic version of a counselor. What ChatGPT is basically is the Eliza moment for everyone else. That this thing, these simple processes of generating strict sequences of tokens on the back of a semantic representation satisfies large numbers of people enough that they seriously think that there's thinking going on.
Yes. Oh yeah, for sure. So, well, I yes, agree with all that, and I think emphasizing the amount of data and the size of these models is
Yeah.
just something that well, there's something magical about that. There's something there that we've benefited from that scale in a way that we don't really understand, and that's a huge difference between now and 10 years ago, 20 years ago. But yeah, the point you make there, I mean, this makes me sort of think, okay, well, people, you start thinking about people and what does it mean to understand things? What does it mean to think? And and to what extent does it matter if the agent you're talking to really understands and thinks in the same way that you do or
Yeah.
not, right? Because it sort of seems to me that humans are very, in a lot of situations, we're very willing to accept um, fakery at the other end,
Yeah.
right? So we're perfectly happy to believe that if we go to a restaurant and the waiter is nice to us and smiling and
Yeah.
joking and stuff, that they're actually having a good time too.
Yeah. 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 Yeah, there's
Um,
elements of social preening and just ritual involved here. I agree 100%. Yeah, like so it's surprising how much of language is just that kind of stuff.
yeah, yeah, and so it seems that large language models have gone a long way to being able to do the kind of emulation that humans are willing to that humans can be satisfied with, and maybe that's okay. I mean, this is where I start wandering into topics I know nothing about, right? Like, is it okay to have AI, AIs acting as psychologists for people, giving somebody to
Yeah.
someone who's lonely something to chat to or to talk about their problems or whatever, and maybe it's okay. Although on the other hand, maybe they could give them some bad advice, um, so there's that sort of side of this, and but yeah, I think even with humans, I somehow it feels to me like large language models and all of this stuff is maybe forces us to perhaps admit or suspect at least that all the higher order cool stuff that we think we have
Yeah.
around intelligence and self-reflectance and consciousness, or that maybe all of this stuff can be fairly easily faked. And we're not really sure what the difference is anymore. You know what I mean?
Yeah, I mean, I think I think there's two lessons that we should draw. Well, there's probably many. There's two lessons kind of related to this topic that we should draw from the history of AI research. The first is that until we've worked out how to do something that currently requires intelligence, our intuitions about how hard or how easy it's going to be are terrible. They've always been terrible. We thought that it was going to be easier to make a robot walk than make it play chess. That was not true. And it's been that process has been repeated over and over and over and over again in AI, that until we work out how to do it, we don't actually know how hard it is or not. The second thing is that the way we measure human intelligence is a terrible way to measure machine intelligence. And I think the reason for that is that this is like, if you're familiar with Goodhart's law, it's one of these kind of like sort of nice principles that it's often quoted as saying, when a metric becomes a target, it ceases to be a good metric. So, and it's particularly true in sort of in business and any kind of like human process when you start that you've got some way of measuring the success of that process that's generally a proxy metric for things you really care about. And when you make it a target, people game the system and the whole thing kind of all falls over. But I think it's not true when it's AI kind of adds a new lens on that, because it's not true if the thing you're measuring is causally related to the thing that you really care about. So think about this. Think about the way that we measure proficiency in the law is through the bar exam, and that's through these written tests. And that's because it's not possible for a human being to learn all of the stuff that you need to do to be able to answer the bar exam without basically essentially of acquiring the skills of being a good lawyer, because it's all the hard work involved of kind of memorizing all that case law, knowing how to apply it, yada, yada, yada. You're basically demonstrating that you know the conceptual things you need to know in order to be a good lawyer. But so just because it's mechanically related in human beings doesn't mean it's mechanically related in machines, because with machines, we can ruthlessly target success at that metric. And there's no reason for us to expect that the mechanical things that cause a human being, that all of the kind of pieces in place that cause a human being to be good at the bar exam will there be in place with an LLM. So just because an LLM can pass the bar exam doesn't mean that we should get it to represent us in court, because it's not the right way to measure whether an LLM is actually a good lawyer.
Yes, that's absolutely true. And I mean, another issue here is that, so not only is measuring human intelligence not a good way of measuring machine intelligence, but we actually don't have good ways of measuring human intelligence, full stop, right? So I sort of sometimes get into this kind of domain when I'm arguing with students about how much marks they should have got for an assignment or a bit of assessment, right? I mean, we assess a student's work. They do an assignment for me, and I'm supposed to be assessing based on that thing that they handed in, whether or not they have learned the stuff, whether they've achieved the learning outcomes that are in my class. But I don't know that, right? I'm just hoping that if they are able to produce this thing that looks like it has the right stuff, that they have truly learned these things. But we all know about, cramming for exams and stuff like that, right? I mean, 1 hour after you've done the exam, you can't remember a single thing anymore about that. So to some extent, humans fake their understanding as well at times, right? And maybe in some situations they can get by on that, and the other people involved are okay. So if that's the case, well, maybe it's okay to have an AI that's enthusiastically part of some discussion or whatever, but actually hasn't, is obviously not.
Well, I mean, I think the difference is, we know that there's a bunch of baseline assumptions we make about other human beings, like the fact that they have agency, the fact that they have a set of values, and that those values are largely shared amongst human beings, even that there's kind of, obviously there's nuances and differences between people, but, some of our ability to navigate those differences in values will interpret from a face-to-face interview, just seeing if it kind of like, HR people will talk about like a cultural fit of like whether, you think you can get along and work with this person or not. And that's partly about like other right social cues there that you can navigate conflict and value differences. So we kind of assume all of that background knowledge, and often those kind of intelligence exams, like take even the issue of cramming, I think it's still reasonable, because what we're testing is, if you had to work in this topic area, are you capable of onboarding all of the knowledge in a way that shows that you can then apply it and solve problems with it? And we don't expect human beings to remember everything they've ever read. We just expect them to be able to onboard that knowledge and apply it effectively. That's what, in most jobs, that's what we expect.
Yes. Yes, that's true. That's true. Well, I'm keen to keep chatting. I realize John and I have been talking for an hour already. We've got a couple of people here with us, so I don't know
Yeah, we should take these questions. Yeah.
if you have any questions, we'd be very happy to hear them, either on your mic or in the chat. I can keep an eye on those. So have a think. Otherwise, we might keep chatting for a little bit longer, John, if you've got time.
Yeah, absolutely.
Excellent. Yeah, so, well, okay, maybe if people are thinking there, we'll make it a bit more awkward here and go beyond the
Yep.
cramming for exam situation, right? So if we go back to my analogy about the waiter in the restaurant being like your best friend and laughing at your jokes and just seeming like they're having the best time ever serving you or whatever, right? So this sort of leads to the thing where we have AIs potentially that become people's friends. And
Yep.
I'm talking, when I say this stuff, it still sounds to me like science fiction, complete rubbish, but I know damn well that there are dozens of companies out there that are already doing this, right? We have companies that are marketing AIs that allow you to talk to your deceased relatives.
Yeah.
So, and this, so this is some, yeah, I guess the underlying question for me is, if we have, I think we can safely assume that the AI doesn't have the same kind of intelligence as us. So if they're just if it's just faking it, and is that okay, for people to be, where we sort of move into a world where increasingly people engage with these agents in this way and just happily accept that it's a bit of a performance, at least on the other end.
Yeah.
What do you reckon? Got any thoughts about that, Sean?
I think it's true that like if you go back to your waiter example, human interactions are kind of complicated, because in a way everyone knows that's a kind of charade in a way. In a way, like, you're interacting with that waiter and you're partly just enjoying the ritual of the pleasantries of the interaction. But there's also a level in which you're also kind of enjoying, wow, this person is actually really good at the social component of their job and kind of engaging me in this. And so actually there's a level, and if you're a decent customer and treating them well, etc., there's also a level of pleasure they get out of the interaction, where they know, like, so it's all like there's a mutual understanding that the surface interaction is in sense a charade, but then there's a kind of an enjoyable interaction above that. Like, so I think, people enjoy, like, so people enjoy the oddity of their interactions with AI. They like the fact that they can get it to say strange things. They like sort of probing the edges and causing it to sort of to say contradictory things or say things that they know that the people who designed it don't want them to say, etc. So there's an element of game playing that's kind of already going in. But I do worry about, I guess the concern is that the broader concern is, what about any sector of society who for some reason or another isn't able to discern that these things are not real people? I think, but that's actually, I mean, that's I actually think um one of the growing problems we face as a society is actually that uh the growing sector of people who prey on the elderly in kind of like various kind of scams and criminal enterprises, but that basically sort of exploit the fact that the world is getting more complicated. There's more systems you have to interact with. There's more technology that the elderly don't understand, and they come up with ways of sort of extracting that money from them. And I've seen plots of the amount of money lost to scams just in Australia, and the growth is beyond linear. It's above linear growth. So it's like it's a massive problem that's not going to go away in a hurry. And I think the like the big tech companies are not talking about it, but the scam industry is the industry that's going to benefit the most from this current wave of generative AI.
Yep. Yeah, I think that's right, and even if it's not a scam, yes, things like um companies that allow you to talk to your deceased relatives or whatever by synthesizing data. Um,
Yeah,
it's
yeah,
kind of exploiting human weaknesses in the in terms of emotion and things like that, which is something that that AIs don't have to worry about, I don't think. So it,
yeah. That one's a tough one. I mean, arguably, yeah, human value, like when you hit the boundary of human values, it gets really hard because like are astrologists doing this, like fortune tellers, kind of people of various religious persuasions,
mm,
where everyone draws that boundary of when something starts becoming a scam is different. And I mean, that's one of the problems of the whole AI ethics area, is that the reason AI ethics is hard is because human ethics is hard. We haven't even solved human ethics. So how on earth are we going to solve AI ethics? Because I
mm,
can guarantee you, it doesn't matter what ethics you program into your AI, there will be a sizable proportion of humanity who disagree with those principles.
yeah, yeah, that's right. Yep. And I think it's, I mean, one of the things I've been sort of thinking, once this whole AI thing really took off in recent years, it seems to me just so critically important that um, these problems that AI faces, like ethics, this is not something you should leave to the computer scientists, right? I've said this a few times. Um, if there was ever a time for interdisciplinary research on a
Yeah.
massive scale, where we have to get computer scientists, neuroscientists, psychologists, philosophers, ethicists, language experts, all of these people need to be in the room, and they have to be willing to meet in the middle somehow. And
Yeah.
that, in my experience, that is not easy to achieve.
It's really hard. I mean, because you've got to sort out the issue of some non-trivial proportion of the people who work in that area will be evangelizing their particular ethical view of how the world should be. So um that's there's that conflict. And then there's the determination of like, how do you even design I was doing a little bit of research about this, just thinking about, okay, how about things like, say, like ethics boards inside universities? Turns out that there's papers from people from other cultures sort of arguing that the ethics boards are, representing only a kind of a particular view of what's ethical and what's not ethical. So it's not the case that there's any one group of people who all of humanity agrees should be the arbiter uh,
Hmm.
of what's right. Um,
Yeah.
I mean, I ultimately, I think this kind of stuff. I mean, it's like there has to be kind of like a gradation in a similar, like it has to be somewhat similar to the way that successful multicultural societies function, which is that you have to determine a core set of principles that are regulated and in some sense a law, but those principles should be as minimal as possible and sort of just like a restricted set of things of human universals as close as you can get to it. And then really the AI marketplace it's like a marketplace of religions. I mean, basically companies who produce these things have to sort of advocate for what their values are, and customers will choose them or not choose them. And then it becomes evolutionary. Like the
Mm.
people will choose AI systems with values that kind of best represent them. That's kind of not what's happening at the moment, because what happens is big tech companies they'll only talk about AI ethics when it's about an issue that they think is significantly sort of uncontroversial, that can win them kind of respect from customers, and anything else they'll just sort of sweep under the rug and not want to talk about.
Yes.
So
Yes. That's right. Um, Gosh, there's a few things I'm sure we could keep talking for hours actually, John, but I don't want to keep you for too much longer. Is there any sort of pet topics that are on your mind lately that you wanted to say something about, and or perhaps something about speculating about the future of, I mean, I don't know, predicting the
yeah,
future is a terrible thing to even try these days, but
yeah.
yeah, what's been catching your
So
attention lately?
um, I, a couple of things. I think that AI will hit a wall at some point. There'll be another some kind of winter. I don't know when it's going to happen, but I don't think I'm extremely skeptical that um, that multi-headed self-attention is going to solve these problems of agency and autonomy and value systems and planning and everything altogether. I could be wrong about that, but I don't think it's going to happen. Um, I think and the other thing that's happening at the moment is the thing that disappoints me the most is um, a lot of the work. You see so many papers where all of the talk is about, hey, we've got an LLM system and it can do this, and it can now we've got one that can do this X, Y, Z. So it's a constant sort of like it's a start from a core and show capabilities. And there's not enough work going on about, okay, let's actually do good science about the bounds. Like, let's find some boundaries and constraints of what you can possibly do with these systems. Because ultimately that's where we're going to discover where that wall is, and the next kind of wave of research is going to happen. So actually back to our earlier topic, I think kind of ironically, in the process of working out what you can't do with LLMs, we're going to come up with a whole bunch of new ways of being able to measure intelligence and measure the nuances, etc., of intelligence. And we may even find that, because, we're just a bunch of primates lumping or lugging around this sort of this lump of meat in our heads with a neural network that's gone through, whatever sort of evolutionary process has gone through. Maybe there's not just even one kind of human intelligence, and we'll find there's actually, like, sort of all of these different sub-architectures, or like things that determine constraints on what you can do with your lump of gray matter.
Hmm. All right, so let me let me give you a bit of a feel, an idea of what I think here. I mean, I don't know what, yeah, I don't know how to measure human intelligence. But but I and I don't know if we're going to hit this wall, but we'd have to define some wall to be able to hit
Mm.
first. So I guess what I'm wondering is whether the AI systems we have built now, um, if you if you exclude all the things that are to do with our embodiment in the world as these, physical agents that live in the real physical world and interact with that physical world via our senses, right? Our sensory system and our physical, experience. If we take that so I don't think that's AI can't do any of that yet,
Yeah.
really. Probably some robotics people might be trying hard to make that happen. But if we don't think about that stuff, then maybe this stuff can do everything that we can do.
Yeah, I mean, like, I think at the moment, the difference is that all the Gen AI systems, they're like a an idiot savant that needs to be micromanaged in a way. Like you can't just give it a task and come back a week and see that it's done. You have to be there every step of the way saying, no, no, that's not good enough. Do this again. Do this part again. No, no, that's, I think you should use, so you, it's, it's, I'm yet to see an example that wasn't fabricated. So there's been multiple kind of made up fabricated AI products released to sort of great fanfare.
Mm,
Everything that I've seen is always heavily sort of user interaction prompt driven, which means basically it's it's drawing on your prompt to basically mean regress from this massive, partially memorized, partially hallucinated data set of what that world looks like. And then you give it more feedback to sort of steer its stochastic path through the space of possible outputs, gradually constraining it to what you want. It doesn't have, we haven't shown something and say, okay, like this is what I want. It goes off and thinks about it, comes up with a bunch of questions, like right back to the start of our conversation, where a simulated data science, we say, here's a data set, I want you to solve customer churn. It can't come back with good questions to ask, and then on the basis of those questions, come up with more questions, and then do some work, and then ask more questions, and then gradually, iteratively generate a product. It in and of itself spawning the questions that come back to it. I mean, it'll be. I mean, you see people doing this, but the techniques they're using are all trivial. It's all sort of like print, read, repeat kind of things where the model feeds back into itself. They haven't incorporated any of the kind of research on sort of planning and optimization and all of the other aspects of thinking that AI has made progress onto. They're just they're under the assumption that because LLM systems can emulate reasoning, as long as that reasoning follows a template that's heavily represented in its training set, that it's going to be able to do this in general.
mm. Yeah, I do tend to think you might be right there when it comes to planning and reasoning where there's depth and complexity in the sort of chains of reasoning that might be involved and uh getting these systems to emulate that is perhaps not possible yet, but I'm also nervous about speculating that
Yeah.
the next diffusion based architecture with more heads and a committee or something on the back or whatever
Yeah.
might be able to do these things, right? I mean,
It's going
I
to need recurrence. I don't think it's going to happen without recurrence. I think you need
Yep.
some way, after it's got a semantic representation, it needs some way of comparing that to a worldview or world model and recurrently working. Like there has to be recurrent, because thinking is an inherently recurrent process, at least as far as we know it in human beings.
Yep.
Um,
Yeah, and I
it's
think, what we're kind of talking about now more or less aligns with, I think, what Jan LeCun's
yeah,
been saying, right? I mean, LeCun doesn't essentially says he doesn't think these current models he calls autoregressive models, which is what they are, and he doesn't think that leads to AGI, whatever the hell AGI is. That planning and other things like that are going to have to be involved somehow.
yeah,
Yes, but I've pushed the models fairly hard in the context of teaching because I mean, disrupting education
yeah,
LLMs have massively done that, and we don't know what to do about it. Um, I can get a large language model to generate code effortlessly to implement pretty much any ML technique that's in the textbook. Um, and I can push it around and ask it to make modifications, and it can usually do a really, really good job of that. What I think, and I think the reason it can do that is because it is able to roughly do a one-step analogy type of thing, right? So it's able to extract some sort of notion of what it means to tidy up the code, let's say, and you can say tidy up this messy code, and it's never seen this code, but it can apply those principles that it's learned from massive amounts of data. That's only a sort of one step level
yeah,
of planning, and I can iterate over it and get
yeah,
somewhere.
yeah. You
But
do.
I think you're right. That's still a very simple one step at a time process that we're at,
You're
right?
doing the thinking. You do the thinking,
Yeah.
and the reflection, the all of the thinking's happening in your head. You're using it as basically this kind of like iterative process of refining it. Well, you don't have to remember the trivialities of the semantics or
Hmm.
yeah, yeah, because they I think there's multiple levels to that. Like I think that we're starting to see papers now that talk about analyze to what extent LLMs are just lookup tables or versus fuzzy lookup tables versus sort of like abstractions. So we
Mhm.
know that there's some kind of higher level abstraction happening, and that's sort of surprised us. But it's disappointing to me how little work has been done to try and quantify that, because basically the whole industry um, profits off presenting the idea that we've created AGI, or like we're on the verge of creating AGI, and there's no incentive for them to reflect on, oh, actually, look, it's 70% just a lookup table, 20% is a fuzzy lookup table, and 10% is these interesting high level abstractions, but we can quantify where they can occur and how it's able to do the kind of things you're talking about. Because for every, like I had the same experience, but I use both ChatGPT and Copilot, and for every sort of successful thing it's able to do, there's also like bananas code it produces because it clearly hasn't understood what I'm trying to get it to do. And the spectrum really is I can almost see it, whether is this something that's like a function that's been done many times before, or am I trying to do something that's really quite peculiar and unique to my particular project?
Mhm. Yes. I think that's how it is, isn't it? Mind you, it's quite nice to almost. I mean, I feel like kind of Harry Potter with my wand at this point, right? Where
Yeah,
I'm pro, I'm writing code by just kind of waving my hand around. Oh,
yeah.
make it do this, make it do that, and oh no,
It's
you haven't got that bit right. Can you fix that up? Or
yeah. It's
or
like it's like having a familiar, like a kind of magician's kind of yeah. It's that's
yes.
But so I think the litmus test though for AGI should be a non-programmer uses one of these tools and produces a functioning app that does exactly what they want it to do. Because then you've seen, oh, it's not benefiting from having the thinking processes of an actual coder helping it actually build a solution. It's actually having to do the whole thing by itself. That's going to be one of the litmus tests.
Yeah, yeah, for sure.
And it has to be, oh, we got a message.
Oh yeah, thanks, Jess. Thanks for joining in.
Thank you. Yeah, that's good. Litmus tests, I think. There's many. I mean, there's another one. The other one, I think, for me, for AGI. I mean, there's a bunch of these like people speculating about, the right way to test it. But I think the test is when you can just give it some kind of white collar job that doesn't require physical embodiment, and that it does it without having to be micromanaged, so it ceases to be a productivity tool and actually becomes an independent entity that you can rely on to do good work. It doesn't have to be work, but it has to be sort of consistently good enough.
Yes, yes. All right. Well, look, I think if we talk much longer, this recording might cease to be useful, John. So, but yeah, look, thanks for that. That was such an interesting chat. We did wander a little bit away from your book and data science, but I think, well, how these things are super important and are impacting data science as much as every other area of what humans do. So yeah, thanks again, John. Thanks for joining in.
Thanks, Marcus. Thanks for having me, buddy. Good to
No
talk.
worries. I'm going to stop the recording there.